In some parts of the sun's surface, there are dark spots larger than the entire planet Earth. They appear, grow, and then vanish, following a pattern that repeats every 11 years. In 1859, one of these spots triggered an event so powerful that it set telegraph equipment on fire in several countries at the same time. Today, NASA and other space agencies monitor these spots around the clock because a similar storm happening now could cause more than $2 trillion in damage around the world. And according to scientists, the sun is in one of its most active phases in the last 20 years. To understand why this worries them so much, first we need to understand exactly what these spots are. Sunspots are darker regions on the visible surface of the sun called the photosphere. They look dark not because they are switched off, but because they are cooler than the surrounding surface. The central part of the spot, called the umbra, sits at around 3,500 degrees Celsius. That may sound extremely hot, and it is, but the rest of the sun's surface around it reaches 5,500 degrees Celsius. It is this temperature difference that makes the spot look dark, even though, on its own, it is hotter than any furnace on Earth. The size of the spots varies a lot. The smallest are about 1,600 kilometers across, but the largest ever recorded exceed 160,000 kilometers, more than 12 times the diameter of the Earth. A sunspot can last from a few days to several months before disappearing. But what exactly causes these spots? The answer is hidden deep inside the sun. And understanding that cause is the first step to understanding why scientists keep an eye on them all the time. The sun is not solid, it is made of plasma, a kind of electrically charged gas, spinning and moving all the time. This constant motion of plasma creates a gigantic magnetic field, similar to Earth's magnetic field, but much stronger and much more complex. In certain areas, this magnetic field becomes extremely concentrated and twisted, almost like a tight knot. At these points, the strong magnetic field stops the heat from inside the sun from rising normally to the surface. That is why these areas become cooler and appear to us as the dark spots. Sunspots usually appear in pairs or in groups with opposite magnetic polarities, one acting like the north pole of a magnet and the other like the south pole. And this magnetic behavior is not random. It follows a cycle of roughly 11 years, during which the number of sunspots rises, reaches a peak, and then falls again. In the middle of this cycle, the sun's entire magnetic field flips. The north pole and the south pole of the sun swap places. Imagine if on Earth, the north pole and the south pole swapped position every decade. That is basically what happens on the sun over and over for billions of years. And it was exactly this 11-year cycle that in 1859 produced the strongest solar event ever recorded in human history. On September 1st, 1859, an amateur astronomer named Richard Carrington was sketching a large group of sunspots at his private observatory in England. Suddenly he saw an intense white flash coming from within the spots, lasting only a few minutes. He had just witnessed and recorded the first known account of a solar explosion, today called a solar flare. Hours later, the effect reached Earth. All around the world, telegraph systems simply stopped working. Operators reported electric shocks, sparks flying from the equipment, and even paper catching fire inside the telegraph stations. The following night in Boston and Maine, 2 telegraph operators completely disconnected their batteries and still managed to keep exchanging messages using only the electric energy that the solar storm was injecting directly into the wires. Auroras, which normally only appear near Earth's poles, were seen in tropical places near the equator. In some cities, the night sky glowed so brightly that people could read a newspaper without any artificial light. This event became known as the Carrington Event, and to this day it is considered the most intense geomagnetic storm ever recorded in history. Back then, the world relied only on telegraphs. Today, we depend on satellites, the internet, GPS, and entire power grids, and that changes everything about what would happen if an event like this happened again. More than 100 years after the Carrington Event, the world got a small taste of what a solar storm can do to a modern society. On the cold early morning of March 13, 1989, in Quebec, Canada, the region's power transmission system simply stopped working. In less than 90 seconds, and with no warning at all, 6 million people were left without electricity. For many of them, the problem lasted 9 hours. For some, it lasted entire days. At the time, no one immediately knew what had caused the blackout. Because the event happened during the peak of the Cold War, many people feared it was the beginning of a nuclear attack, especially because the sky was covered by intense and unusual auroras. The real cause was a coronal mass ejection, a burst of solar particles that traveled through space and struck Earth's magnetic field directly, overloading Quebec's electrical system. This blackout was only a preview of what happened 35 years later, when the sun produced the strongest storm in 2 decades, right before our eyes. Between the 3rd and the 9th of May, 2024, NASA's Solar Dynamics Observatory recorded 82 significant solar flares, coming mainly from 2 extremely active regions on the sun's surface. 9 of these flares were classified as Class X, the strongest category that exists for this kind of event. The result was the strongest geomagnetic storm the Earth had faced in 2 decades, and according to some researchers, possibly one of the most intense aurora displays in the last 500 years. Auroras were seen in places that rarely witness this phenomenon, including parts of the southern United States, Mexico, and even near the equator in some spots on the planet. This time, thanks to decades of technological progress and constant monitoring, power systems and satellites were able to prepare in advance, and the damage was much smaller than it could have been. This May 2024 event was not an isolated accident. It was part of something bigger that was and still is happening on the sun. In October 2024, NASA and the American Oceanic and Atmospheric Agency, NOAA, officially announced that the sun had reached what is called solar maximum, the peak of the 11-year cycle we are in now, named Solar Cycle 25. The interesting part is that no one expected such a strong cycle. In 2019, scientists predicted that Solar Cycle 25 would be weak, similar to the previous cycle, which had been the weakest in 100 years. But the sun surprised everyone. The number of sunspots rose much faster than predicted, and the peak arrived earlier than expected. On the October 3rd, 2024, Solar Cycle 25 produced its strongest explosion up to that moment, a Class X9 flare, one of the most intense events ever measured in this cycle. And the sun stayed active after that. In November 2025, a new region recorded a Class X 5.16 flare, the strongest of the year, releasing a coronal mass ejection so fast that it traveled at nearly 2,000 kilometers per second, forcing American scientists to issue a severe geomagnetic storm warning. And while the sun kept up this intense activity, NASA decided to do something never done before in the history of space exploration, to send a probe into the atmosphere of the sun itself. On the 24th of December, 2024, NASA's Parker Solar Probe did something no object built by human beings had ever done before. It passed just 6.1 million kilometers from the sun's surface, entering directly into the solar corona, the extremely hot outer atmosphere that surrounds the star. For comparison, the Earth sits about 150 million kilometers from the sun. The Parker Solar Probe came 24 times closer than that. During this approach, the probe reached a speed of approximately 692,000 kilometers per hour, the equivalent of 192 kilometers per second. That is the fastest speed any human-made object has ever reached. The probe was designed with a special heat shield able to withstand extreme temperatures, while the scientific instruments behind the shield stay at room temperature, protected. Since then, the Parker Solar Probe has already repeated this same record distance several times, including a pass in December 2025, collecting data straight from inside the sun's atmosphere during this phase of extremely high solar activity. This data is helping to solve mysteries that science has been trying to understand for decades, but it is also confirming why this period of the sun deserves so much attention. When the sun is in an active phase like now, with many sunspots and frequent flares, the risk of strong geomagnetic storms hitting the Earth also increases. The problem is that today's world depends on technology in a way that the world of 1859 never did. A strong solar storm can affect GPS signals, causing navigation errors in planes, ships, and even in your phone. It can interrupt radio communications, including those used by emergency services. It can damage satellites in orbit, shortening their lifespan or knocking some completely out of operation. And most worrying of all, it can overload entire power grids, causing blackouts similar to Quebec in 1989, only on a potentially much larger scale. According to estimates from the United States National Academy of Sciences, a solar storm the size of the 1859 Carrington Event, happening today, could cost almost $2 trillion in the United States alone, considering the damage to infrastructure and the disruption of essential services. A risk model from the insurer Lloyd's of London reached an even higher estimate of up to $2.6 trillion in damage to the American economy, in an event comparable to the one in 1859. That is why agencies like NASA and NOAA monitor the sun 24 hours a day, trying to predict solar storms with the same seriousness that meteorologists predict hurricanes. The sun is 150 million kilometers away. For most people, it is just a source of light and heat in the sky, something we don't even stop to think about during the day. But the dark spots on its surface are the visible proof of a gigantic magnetic process, one that has already shown it can directly affect life on Earth, even from so far away. Today, with solar cycle 25 in one of its most active phases in the last 20 years, and with probes like the Parker Solar Probe bringing data from inside the sun's own atmosphere, scientists have more information than ever to understand this behavior. But predicting exactly when and where the next great solar storm will happen remains one of the biggest challenges in modern space science. What we know for sure is that the sun has done this before in 1859, and again in 1989, and again in 2024. And sooner or later, it will probably do it again. The question that remains is not whether a strong solar storm will happen again. It is whether, when it happens, the world will be ready.